We're going to start out with public service announcements. And the first one is about ExpressLRS receivers. Blunty, I'm going to start with the wild claim that started this story. Then you and I was like, are we going to cover this? And you were like, let's do some research and actually, so I'll share the wild claim and you'll be the reasonable person who did the research. The wild claim is, there was a Reddit thread about this. Maytech receivers are defective, ExpressLRS receivers. They're defective, they fail safe when it gets hot because they're badly designed. And the oscillator is out of spec, and you need to take it off your website, Bardwell, and let everyone in the world know. Yeah, is that right or
that sounds
wrong?
About right.
Okay.
So that's why, that was the consensus for that was the noise on Reddit and stuff. And as we know, a lot of places get overblown or pushed in one direction for a narrative. So I tried to dig a lot in. Credit to Captain Bry and a lot of the other guys. I mean, I got tons of information from multiple people. Flight control, I don't know what he wants to go by, but right now it's Bang Bang My Excel, helped me a lot. Just a lot of folks, V22. So anyway, we went through a lot of the information. They shared with me a lot of the stuff that they got back. Sunjun has this page on the wiki that we can pull up here, which is basically a page all about this problem. And so we've talked a little bit before when the JHEMCU stuff was identified, and we discussed a little bit of this, but we didn't go super into detail. And I think because we're seeing so much of this now, I think we should talk a little more about what's happening, right?
Yeah.
So these pictures that we can see here basically are the problem. So ideally, everybody's living on a reference frequency, right? So ideally, the idea is that everything is designed such that they have the proper amount of, and I'm not technically literate on this perfectly, I'm just getting this from other people and what I understand, but the idea is that you have the correct amount of capacitance there because there's some default in the SX1280 chip. And that go ahead.
Let me back up. I think you jumped ahead slightly. Can I back up? Back up slightly? So they transmit at a frequency like 2.4 gigahertz. And the question is, how do you, well, it's actually in a range, but they have to agree on what 2.4 gigahertz is. And they do that with an oscillator.
So my point was, like, in normal environments, your goal of the reference frequency is having the correct amount of capacitance to hit your proper reference frequency. Right. And then your TX and your RX need to be on the same reference frequency. So they need to be around the same number. So the offset is almost zero. That's because there's an issue with oscillators, right? We use typical crystal oscillators that are not like temperature resistant. Like they don't adjust based on temperature. They will just go out of spec. So one of the things that we want to do is, for instance, right, if we have a transmitter, that transmitter is naturally going to heat up over time. Right. So that transmitter is going to start to go out of spec in one direction. And the goal is to keep them within a 200 kilohertz offset. So the farther out of spec any one device is, the harder it is to make sure that each of those, any devices that talk together are going to be okay if there is any temperature variation or any other variation that happens. So, that's why that's the importance of being at the reference, right?
Yeah. So we've got these oscillators. The oscillator controls the frequency. And the oscillator changes frequency as temperature changes. And if we were willing to spend more money, then we could build circuits that didn't do that. But instead, what we do is we just, and by we I mean manufacturers like Happy Model, JH, etc. We just ballpark it. They want the frequency to be a little bit off this direction, and then as it heats up, it drifts that direction, and it tries to basically be close to correct.
Yeah, the goal should be hit the reference frequency at room temperature when you're doing testing on the bench to show that you're good to go. Right? That's the idea. And that should happen once you have your full design done and your full receiver out and all that kind of stuff. So,
but it does drive home that this is not a trivial thing. When we talk about some manufacturers have done this wrong and their receivers are out of spec, it's not quite as simple as, well, you just didn't pick the right thing and you screwed up. They're trying to kind of hit a range, and they should be able to do it, but...
Well, so I guess the one way an electronics engineer explained it to me is basically you should have a set of specs that you can math out to know how this should be designed based on all the reference information. So you're either missing a piece of information or you've done something wrong in your design. And then once that's set, then you take that and you test it. So there's basically two steps there, right? One is the design has to be correct to what you should actually be doing. And 2 is that design should be tested once it's built.
Yes.
And like both of those have to fail essentially for a batch to go out that's bad, is what, basically is the case. Okay. So like, well, I understand what you're saying. It should be like, you kind of got to get close, but if you set everything up correctly and you have the proper people working on this stuff, or again, you're communicating with ExpressLRS developers who are actively interested in helping people, then they're happy to tell you and help you get this correct, right? So that's part of this.
So the claim is, here, let me come back to us. The claim is that these Maytech receivers have been built incorrectly so that the frequency is out of spec and they fail safe, especially when they heat up and the frequency, maybe they'll bind when it's cool, but then as it heats up, it goes out of spec and they fail safe or range gets short.
One of the problems is, and we could look at the XO offset on this page here. If you scroll down, there's a list of tested offsets, and this is all of them, but this is what we have so far. But the problem is some receivers go down when they're iced and up when they're heated, and some receivers go up when they're iced and down when they're heated.
Oh, okay.
So there isn't a general rule as to like, oh, if it gets hotter, it's going to do this, or if it gets cooler, it's going to do that. So unfortunately, there's no like, this is the whole goal of getting to that reference frequency, so that we don't have to worry about any of that. If it goes one way or the other, right, we're covered but in 100 kilohertz in both directions. That's sort of the idea. Yeah. But here we can see from this list that we could see the JHEMCUs in yellow and orange that we looked at before. They're way out of spec, and it appears that even with cap removal, they're not really. There's not a good way to fix those.
Let's back up again. You said cap removal. So what's happening with some of these designs is that the oscillator they're using doesn't have the correct capacitance for what the reference design is supposed to have, which means that its frequency is wrong. And then they try to fix it by adding capacitors on the board, and sometimes that results in it being out of spec. And so some manufacturers, I think Maytech has said, well, if you have an ExpressLRS receiver that's affected by this, just desolder these capacitors and then it'll go back into spec. And that's what you mean by the cap removal.
Sure. We should be clear that it does not go necessarily back into spec. Like, it's still, if we remove those capacitors, on average, it looks like we're getting something like, we're going from, I believe the average is like a 144 on the best side. Like, I've done a lot of research into this from people, but we see here it's about 144 to 150 something on the Maytech tests here. And then if you pull the caps off, we're still at like a
just
plus
barely.
90.
Yeah, we're at plus 90, just barely within spec.
Right, and so and really the goal should be to be at reference at room temperature, right? And so the spec would be at reference, so we're still 90 off that spec.
Right. So even though this is within the safe range, it's still just barely. And one of the things people have pointed out, Blunty, including yourself, is if the receiver is just barely in spec, if you happen to get a transmitter that's just barely in spec the other way, then you can still end up with something that fail safes.
Right, it's the offset between the two, which makes it difficult in this whole situation, right? So it seems like in many of these cases, removing the caps doesn't help. However, one thing we want to mention here is if you go back to our news article, at the very bottom, I've got an imager link of two Maytech example RXs we just want to show. And we'll show the response in a second, basically, to our inquiry here. But one thing that we have here is two different ones. So the top one appears to be a good RX. It's got a gold button on the top left. We can see that. It's got a little bit bigger size inductors, and it's got a MYS P1 marking on the crystal in the lower right corner there. And then on the bottom one, that's one of the bad ones. It has a different marking on the crystal, has silver buttons, and it has smaller inductors. So currently, the identified batch, every tested silver inductor has been bad. And
silver button.
A silver button, with the smaller inductors and the different marking has been bad. The bottom ones have been bad, and I'll explain in a second. And the top ones have been acceptable. The difference is that when we say bad, the bottom one might work for a ton of people, right? Because we've been talking about temperature offsets, right?
Right.
So if you're okay and in the good range, maybe TX has no offset or anything, and your RX, and maybe your TX only heats up and is offset of 40, and you're okay because you're within that 180, right? There's cases where this will be fine. But there's also many cases, edge cases, where it could happen where one thing heats up or the other cools down or whatever, and you have a case in flight where you've had a loss. So, we would hope, like all the JHEMCUs, in most cases, they just don't bind if they're bad. Right, because they're so far out of spec, they just don't even talk.
We go back to this chart. We can see the JHEMCUs are super out of spec, and just nowhere close.
Yeah, And so with those, like, they don't even bind, right? So in a lot of cases, the user can tell there's an issue because they don't bind. But in these Maytech cases, there are going to be edge cases where users are going to use these silver button RXs. They're not going to know there's any issue. They're going to bind up fine, and then they're going to fly on a super cold day or a super hot day, and their quad's going to heat up, or their TX is going to heat up. Like, that offset could happen and could cause a failsafe you do not expect.
So what we could take from this, I'm surprised by this chart, Blunty, because like I had heard about the JHEMCU receivers being bad, and this bears that out. But like, I always thought of Happy Model EP2 and EP1 receivers as one of the most solid. Several of them are out of spec, and that surprises me.
Too. There's also variance there too, which is another issue, right? We don't know.
Yeah.
One of the other issues we have here, from what we've heard from Maytech and other messages and stuff, it appears to be that there's one batch of silver buttons, and that seems to be the same from testing. They all appear to be the same with the same size inductors and things. The gold buttons were later batches, and there's 2 batches of gold buttons. But we don't know how many batches of any of these were made, right? We don't know how many Happy Metal EP1s there were, or what batches each are from. Like, that stuff is very hard information to get. So the best we can do is, do some bulk group testing and see how many of these have issues, and then share that information. So the other big one is the Jumper Aion. We should scroll down and just point that out. The difference is with the Jumper Aion, for some reason, because of what they used, if you just pop the caps off, they're like right in line. And for some reason, they decided to put caps on and pull them way out of spec.
Now, one thing I want to say is that even if your receiver binds just fine, if it is at the edge of spec, you're going to see decreased range compared to if they were perfectly on spec. Do you agree with that, Blunty?
I'm not sure that that's correct. I thought that was correct initially, but I talked to them about that, and it seems like you won't see much difference until that's gone. And for most people, it won't disappear. It'll just be good because you're still within that range.
Fair enough.
I could be wrong on that. Maybe somebody will correct me, but I believe I said that, and then somebody corrected me to say that as long as you're within that offset, you should be okay, and you won't really lose any like link budget there.
Captain Bry confirms that. Interesting. That surprises me, but I believe Captain Bry. If you are curious about how much error there is between your receiver and your module, you can do this thing, which is on this page linked in the show notes. I'm not going to go into details, but it lets you get that information from your telemetry, and you can see how far out you are.
Yes.
All right. So we want to...
this is the part where we got to look at Maytech's response.
Yeah, because Maytech got accused here, and you dove in with them.
Yeah,
and
so
they talked to you.
Let's look at what I sent, because I feel like my email was pretty good here. I basically said, hey, I'm reaching out. I'm doing a segment on the news. These receivers have been identified to have offsets, that have issues. Also appears that receivers with gold buttons don't have the issues, but older silver buttons do. Based on this idea, which is something I believe you sent a previous support message, which I've seen, and I showed all the testing. I talked about confidence interval and stuff. I said, are you placing these? If a retailer reaches out, are you working with retailers? Moving forward, will designs be changed? Stuff like that, right? And their first response was nothing to do with button color. So that goes against what they said before, but from what we can see from the designs, that's not correct. The silver buttons do appear to be the problem. However, they say we may replace the button according to the purchase batch. So it sounds like to me that they're not afraid to use the silver button later, and there may be good silver button RXs later that we don't know about, right?
Yeah.
The other thing is they say the load capacitor must be matched with the crystal selected. We adjust the load capacitance according to the crystal in different batches. ExpressLRS experts say the load capacitor is not needed. We totally disagree with this statement.
Well, and what seems to be happening there is that the ExpressLRS reference design specifies a certain crystal with a certain capacitance and so forth. And when manufacturers can't get that exact component for reasons which are, welcome to 2022, they sub in a different one and they try to correct for that with external capacitors. And there's nothing fundamentally wrong with that approach, except if you don't get it right, then your shit doesn't work.
And there likely should be cases where that is true. Like there are cases where we would expect that needs to happen. So it's just a little bit confusing with that statement. And then I got the second statement, which we want to show. Which is basically they responded basically 30 minutes after that and said, as far as I know, many TX manufacturers don't use load capacitors according to ERS guide. I can only hope they source a proper crystal with stable supply. Otherwise, just like this. And then gives us an example of a comment from Captain Bry on the ExpressLRS Discord, who talks about a TX with some offsets that they had on the TX. So one of the things I want to point out here is, like, to me, this seems like playing the blame game or something, right? I messaged them saying like, are you going to replace these for customers? There are issues and stuff. And it seems like, their replies are basically like, we don't think there's any problem. We disagree with the statement that we should not apply the load capacitors or there's a problem. And here's an example of a TX that's a problem. So what's the issue? Right, basically is what that's how that reads to me. And then the last response I want to show is a response from them from a few months ago, from March, but it seems to be still their attitude. It's one of the last comments by Maytech Samson. He says, since the ExpressLRS TX hardware, RX hardware come from different manufacturers with different crystal oscillators, errors between each other are unavoidable. And so, from what we've pointed out today, I think we've shown that that's not necessarily the case, because that's the goal of the reference frequency, right?
That's the thing. Here's the thing. Like, at the end of the day, you want to be at 2.4000000 gigahertz, or to some number of decimal points, right?
Whatever.
At the end of the day, if I take your receiver and I put it on a high-end frequency measuring device, and it says you're not at 2.400 whatever gigahertz, then you're wrong. So this idea in this message that the message from Maytech seems to be promoting is that, well, we're up here and they're down there and shit happens. Either you're right or you're wrong in the frequency that you're outputting.
And so I just want to point out, as we mentioned, the two gold button receivers seem to be at least within acceptable ranges, right? The two newer batches appear to be within acceptable ranges. And that follows with, they said they were sourcing 3 crystals. So that kind of makes sense. If there's 3 different batches is what it appears to be. However, their response appears to be like, if we get a bad crystal again, we're going to put caps on it again, and this will happen again. Like for me, the way I read that, they didn't learn anything, or they're not admitting to anything, right? So it makes me worried about future products from them if that's their stance. So that's sort of why one of the reasons I want to point that out is because it's not like they're saying, oh, we understand now. We talked to developers. We've been actively discussing. In fact, the developers have been tagging Maytech Samson, and instead they were quoting to me in an email on something from August 10th in the Discord, but they haven't responded since like May. So
why aren't they more active in the Discord, since we know they're there?
Like, respond to the it feels odd to me, and we're at least presenting that to you today, so you understand where it's at.
Well, it's a hell of a PSA. We're 20 minutes into the stream. We've finished the first story, but there were a lot of details there that I thought it was worth diving into. The takeaway is that if you have a Maytech receiver or any receiver that's having this problem, things seem to almost always, if not always, get better if you remove the capacitors. So try removing the capacitors, I guess.
Yeah, for what we've seen, every single instance of removing capacitors, and Captain Bry also confirms that, they move towards the average, towards the reference frequency. So far, all the capacitors that have been added have not been positive. Nobody knows really why. I've discussed a lot to try to figure out like what's happening and what are they doing wrong or what's confusing. But I think at the end of the day, they're not testing to the reference at the end, and that's the problem, right? And,
well, why would they test? They just come up with a design, and then they run them off the assembly line, and they ship them. Why would they test them?
One thing I'll say is we saw images from Maytech's test equipment. We saw that they have test equipment, and there's some kind of loop rig they have. And so it was pointed out that if that is the case, it should probably be considered that you should maybe test in a different way. And so you can test, there's a CW frequency from an SDR you can test, or you can use a TCXO-TX unit, which some people have been testing with, which means that's a temperature controlled crystal. And basically the TX unit will always be on reference for you with temperature variations. And then you can use that with the debug flags that we talked about to actually figure out your offsets if you need to know, right? There are ways. So.
Well, once a long time ago, I was working on a network install, and we had a cabling contractor who was pulling cable for us. And all of our wireless links had a shitload of corrupted packets. And we spent days trying to troubleshoot the wireless links, and they checked out. And finally, we checked the cables that this guy had pulled. And there's a particular order that the wires on an Ethernet cable are supposed to go. And there's a particular order that the wires on a phone line are supposed to go. And he had wired our Ethernet cables like they were phone lines. And as a result, they were corrupted packets. And I pointed it out to him, and I was like, I don't think this is right. And he looked at it, and he was like, no, that's the way I've always done it. And I showed him the reference, the paper, and I was like, no, this is how it's supposed to be. And he was like, that's how I've always done it. And I was like, well, that don't make it right. You're just telling me this is not just a one-time fuck up. You've been doing it this way for years. You've been installing. So like the idea that, we have this test equipment. Well, if your shit's fucked up, then the fact that you have test equipment isn't helping your story. All right.
Yeah.
Alrighty. Well, this is one of the challenges with ExpressLRS being open source, made by multiple manufacturers. It's the same as with Betaflight flight controllers. Some of them are good and some of them are bad, and you just, if you're not okay with that, then buy Crossfire or buy Ghost, because or just sort of get down in the weeds and figure out what's good. So, all right, let's move on. We got another public service